three formulas, which is the arc length. Arc length is the length of this line here, part of the full circumference, and then area of the sector, and then area of the segment. So segment is this section here. Right? Alright, so we're going to prove these formulas, and only these two are on the formula sheet, on reference sheet. But the last one's not on the reference sheet, so we'll have a look. So that's the reference sheet. So they give you the length of the arc and this one, but not this one, but not the segment. They also give you 180 is pi radian. So we'll go back to this. Okay, let's prove these formulas. The proof, you don't need to know how to prove, but we'll just prove it so that you know where they come from. Okay, so to prove this is very easy because we know the definition of radian is L over R. Now, L over R. Remember the formula we learned at the beginning of this booklet. If you divide the arc length by the radius, you get the angle in radian. Therefore, to work out the arc length, all you have to do is to multiply both sides by R, and then you get cancel, and you end up getting L equal to R theta. That's the formula to find the arc length. It's very important to note that theta is in radian. Theta is in radian. Okay, any question? Arc length. And then we'll look at the area of the sector formula. Area of the sector. Area of sector is, what you do is, you can find the ratio of angle equal to the ratio of area. Actually, ratio of area of sector to circle equal to the ratio of angles. Okay, so we'll use this rule to help us to prove it. So the ratio of area of the sector, which is area of the sector, over the area of the circle, which is pi r squared, equal to the ratio of angle, which is theta, over 2 pi. 2 pi because for a circle, the angle is 2 pi revolution. And then we can find the area of the sector by multiplying both sides by pi r squared, pi r squared, pi r squared. Like that. Okay. So if you multiply both sides by pi r squared, but pi r squared get cancelled, the pi get cancelled, and you're left with the half. That's where the half comes from. So you get half r squared theta is the area of the sector. Okay, again, that's on the reference sheet. All right, and the last bit is area of the segment. All right, how do I get the area of the segment? You can think of the segment, which is this bit here. Let's make it large. This bit here, which is the segment, equal to the sector minus the triangle. Right? The segment equal to the sector minus the triangle. Okay? So let's draw this. This is theta r r. This is theta r and r. So the reason why they don't give you, because area of the sector is on the formula sheet. Area of the triangle is also on the formula sheet. You use the trigonometry formula, half AB sine theta. So, or sine c. So you go half r squared sine theta. Like that. Yeah. And then you can factorize the half r squared out, which becomes the area of the segment. So you can either quote this formula in the exam or derive it each time. Done. So we got all three formulas. We're going to apply these formulas on the examples on the next page. Okay, good. I'll leave it there for a minute. Okay, let's move on to the next page. We'll do an example. You say find the area of the shaded region below. See, that's the shaded region. This one's pretty easy. So what you need to do is to find the area of the big sector minus the area of the white sector. Okay, so you go, area of the shaded will be area of large minus the area of the small. So which is half r squared. So the radius of the big one is 10. So you go half times 10 squared. The angle has to be in radian. So what's 90 degree in radian? On to like this. If you put 90 degree, that would be wrong. So then you go half times another side, which is 5 squared. 5 is the shorter radius, times 5 pi on 2. So your answer will be in terms of pi. You have to get it in exact form. Okay, like this. Okay, let's work this out. So you get 100 pi over 4 minus 25 pi on 4. They have the same denominator, which you can subtract. We get 75 pi on 4. 75 pi. Yeah, okay, good. So that's in square centimeters. Let's enlarge this. Okay, so you can see. Okay, good. Okay, area is done. Area is pretty easy because you just go the big one minus the small one. The other bit is perimeter. To get the perimeter, it's a bit more tricky. Not only have to find these two, you also have to add these two as well. So there are 4 sides you have to add for the perimeter. So let's do that. So the perimeter consists of AE plus arc AC plus, so you go around the figure, plus DC plus arc ED, like that. And let's add them up together. So A is 5. So 5 plus arc AC, use the formula. The radius is, arc AC is the big one. So you have a bigger radius. So you go, so the formula is r theta. So the r is 10, the angle is pi on 2. And that, plus another 5. And then the last bit, the radius is 5. 5 times pi over 2. That. And then we're going to collect like terms. Simplify and collect like terms. Have a try. Okay, good. All right, let's continue. So 5 plus 5 is 10. And this will be 10 pi on 2 plus 5 pi on 2. The reason why I didn't simplify, I want to make them the same denominator. And then 10 plus 5 is 15. So you write 15 pi over 2 plus 10. Okay, in centimeters. All right, good. Okay, done. All right, any questions? Easy. Okay, then we'll do the next bit. Find an angle in degrees subtended by an arc of length 12 with radius 5 centimeters. So we'll draw a diagram. So you have a sector. Okay, a sector, and then with the angle you have to work out in degree, and the length of the arc is 12, and the radius is 5. So in order to find the angle, all you have to do is to use the arc length formula, L equal to R theta. And you substitute all the information, so the arc length is 12, radius is 5, you solve for theta. To solve for theta, you divide 12 by 5. And then if you use your calculator or do it by hand, you get 2.4. Now, what's 2.4? Radian, okay? C. Okay, be careful. The formula, the theta, is always in radian. But the question asks you to work out the angle in degree. So how do you change it to degree? Therefore, what's the angle in degree? So theta degree will be 2.4 times by 180 over pi. 180 over pi. And you don't leave your answer in terms of pi. You work out, correct to the nearest degree, and use your calculator. So you go 2.4 times by 180 over pi. Okay, good. Round to the nearest degree, or maybe to the nearest minute. Okay, so 31 minutes, so 137 degrees, 31 minutes. Like that. So be careful. So this formula gives you the answer in radian. So your answer has to be changed if they want to work out the angle in degree. Okay. Alright, 2 more pages to go through. We'll go through a longer question, and then we'll go through a maximum minimum problem. Okay. Alright. Hopefully all done. Okay, good. Let's move on to the next page. Okay, good. Let's move on. Okay. Example 17. Evaluate the following. Leave your answer in terms of pi. Let's start with the first one. Find the length of the minor arc. This is a minor arc because it's a shorter arc. The other arc is the longer arc called the major arc. So this is called the minor arc because it's a shorter one. And the other one is called the major arc. Major. Okay, they want you to find the minor arc. Let's work out the minor arc. The minor arc, subtend 150 degree at the center of the circle, radius 7. Find the exact form, the length. Right. Okay, so what you do is, first you have to convert the 150 degree to radian. So, which is 150 times by pi on 180. Leave your answer in terms of pi. So you do 150 over 180, which should be maybe 5 over 6. 5 over 6. So you say 5 pi over 6, that's the angle in radian. Once you get the angle, you just use the formula L, which is the arc length, is r theta. So r is the radius 7 multiplied by 5 pi over 6. And then you just simplify that. That will become 35 pi over 6. Okay, done. That's the arc length. And then you find the area of the sector in exact form as well. Use the area of the sector formula. And then we'll find the area of the segment as well as the length of the chord. Then we'll do a maximum problem. Okay, good. Next one, area of the sector. So sector is, we've already got the angle, half r squared theta. So what do? Half times radius 7 squared multiplied by the angle in radian, which is 5 pi on 6. And then you just work out. So to do that on a calculator, do not put pi on a calculator because it gives you a decimal. So put 1 over 2 multiplied by 7 squared multiplied by 5 over 6 equal. You do that, again, you don't put the pi there, you do 245 over 12. 245 over 12 pi. They have a unit. These are all in meters, so you put meters. Square meters, this is meters. Alright, good. We're done. So we did the area and the arc length of the minor arc. Okay, any question? Okay, now we have to find the length of the chord. We haven't got the formula for the chord, isn't it? There's only area of the segment, area of the sector, and length of the arc, but not the length of the chord. Which one's the chord? This is the chord. Let's find this length. Now this one do not require you a new formula because this is just the length in a triangle. So think about which rule we should use to work out the missing length in this triangle. Which rule will be useful? Anyone? Which rule? Yep. Cosine rule. Let's use the cosine rule. So we use the cosine rule to work out AB. So right, AB squared equal to 7 squared plus 7 squared minus 2 times 7 cos 150. Maybe I should write down the formula first. The formula says C squared equal to A squared plus B squared minus 2AB cos C, which is what I did. Okay? So I put 7 as A, 7 as B, 2 times 7 times 7 cos of the angle 150 degrees. Alright, okay, so be very careful now. Check the calculator is degree, not radian, because this is in degree, isn't it? Or you can put the angle in radian, then you put it in radian mode. So just be careful. If you put degree, you have to put it in degree mode. Okay, let's work this out. So you go 7 square plus 7 square minus 2 times 7 cos 150. Like that. 182.87. 182.87 dot dot dot. And you must remember to square root your answer. Square root answer. Like that. 13.5. So just leave to 2 decimal place. 13.52. 13.52 meters. Okay, done. Right, like that. And then finally, we have to do the area of the minor segment. And the formula is not on the formula sheet, so you just have to remember to do area of the segment. Area of the segment is, you can think of it as area of the sector minus the triangle. So if you can't remember the formula, just do this. Triangle. And the triangle is half r squared theta, not half r squared sine theta, and the area of the segment is sector is half r squared theta. So you do it like that. You can derive it each time, so you can half r squared theta minus sine theta. Like that. And then you substitute. Now the radius is 7, so you get half times 7 squared. That angle here has to be in radian. You have to put 5 pi over 6. And this one, you can put 5 pi over 6 or 180. But if you put 5 pi over 6, make sure you do it in radian mode. Do it in radian mode. Okay? Alright, and then you use your calculator. So you go 1 over 2 multiplied by 7 square multiplied by bracket, and then this 5 pi over 6 minus sine. Oh, I forgot. Actually, that's okay. Degree, I could just go sine 5 pi 5 pi over 6. But I just have to tell the calculator this is a radian. So you go press shift, answer. You choose radian, which is R2. Right? That will tell you, even though it's in degree mode, it can tell the calculator this is in radian. I think that was okay. 51.89. I think it's right. 51.89. Or if you didn't do that, if you didn't put an R there, it gives you a different answer. So what you do is you just put your calculator in radian mode. 4, so it's R now. Press equal, give you the right one. 51.89. All right, good. Correct to 2 decimal place, which is square meters. All right, done. Okay, any question? All right. Okay, think about all these things. So we're going to do a harder question that involves maximizing, minimizing. And then you can start the work from the worksheet I gave you. All right, some maximum, minimum problem. All right, let's do that. Next page. Okay, so we're going to look at this, which is a piece of wire L is bent to form a sector of radius R. So that's made from one piece of wire. So a piece of wire L, that's the wire, has been bent. To form this. Okay, so we have to prove a formula. If the sector subtends an angle theta at the center, show that L equal to this, and find an expression for theta in terms of L and R. Okay, let's do the first bit. to find this L, we're going to have the arc length, arc. So L equal to R plus arc length, right? Arc. And R plus R is 2R, and the arc length is R theta, isn't it? Using the formula we just learned. So this is the formula we'll try to prove. That's the first bit. The second bit is to find an expression for the angle in terms of L and R. So we have to make theta the subject. How do you make theta the subject? Subtract both sides by 2R. So you write minus 2R. So we get L minus 2R equal to R theta, right? And then to make theta the subject, you divide both sides by the radius. So you end up getting theta. So you write theta equal to L minus 2R over R. Right, so we're going to use that formula later on when we do part B. Right? And then we'll have to find the area of the sector. Right, how do we find the area of the sector? Right, area of the sector, we know that from before, is half R squared theta. See, that one doesn't have theta because they replace theta in terms of L and R. So let's do that. So half R squared, replace the theta by this, which is L minus 2R over R. Okay, so hopefully we can prove this formula. I may have made a mistake. Why is it 4? Half R squared. Maybe not a quarter. Anyway. Okay, let's proceed anyway. Half R squared, show that the area is this. Yeah, anyway, let's prove it. So we got the R get cancelled, so we end up getting half R L minus 2R. Maybe it's not a quarter, maybe it's a half there. I'll go double check. I think it's half. Okay, I think it's half. Okay, so that's the formula for the area of the sector. And then what we do is we're going to show that the maximum area is maximized when the radius is a quarter of the length of the wire that you cut earlier. So what we do is we have to differentiate it. And to differentiate, we have to go half time, we have to expand it. We have to expand, so you get half R L minus half R times 2R, which they get cancelled. We get half RL minus R squared. Okay, we get that. And then what you do is we're going to differentiate in respect to R. You have to find the radius when the area is maximized. And keep in mind there are two paranumerals, but L, being the length of the wire, stays fixed. Length of wire does not change, the constant is constant. So that doesn't change. So that means when we differentiate it, we treat it as a number. So we do half L. So if I differentiate half RL, it becomes half L because the R is 1, minus 2R. And to find the maximum, you have to make that equal to 0. And solve for R. Solve for R. Okay, so to solve for R, what you do is you do half L equal to 2R, and then divide both sides by 2. Divide by 2. Oops. Times by half on both sides. Times by half, That 2 get cancelled. So you end up getting r equal to a quarter L. R is a quarter L. And then after that, you have to show it its maximum. To show its maximum, find the second derivative. Hopefully this is still known to you. Differentiate half L is 0. Differentiate negative 2r is negative 2, which is just negative 2. Negative, what does that indicate? This is a maximum because it's concave down, so therefore A is max when r equal to a quarter of the length of the wire. So if you make the radius the quarter length of the wire, you will ensure that the sector you folded has the maximum area. Okay, all done. So you will do the worksheet from today. So I'll just show you the work, which is over here. So why do I give you worksheet? Because in the textbook, it has got 3 exercises, 5.3, 5.4, 5.5. So let's do just one worksheet, which contains everything. You may like to do a few easy and do some hard ones. Okay, do some selection of both. Okay, you don't have to do all of it. Do some easy one, do some hard one. All right, up to you. Okay, you can start now. Make sure you write today's date, which is 11th of May, 18. Yep, you can. Go back to the notes so you can continue to copy if you didn't finish. Okay, finish.